Hello students, this is Yashodhari. In this video, we know about the transformation process. How the transformation will be done in a computer graphics. Okay, let's start. Okay, what is the meaning of transformation? Here, transformation is nothing but we can change the given object in the form of a size or is a position and in the angle way. Okay, so basically a transformation is a process where change or manipulate the given polygon or a object's orientation. Orientation is nothing but in the form of we can change the size or in the angle or a position. Okay, these are three basic ones. Okay, so there are two types of transformation, that is two dimensional transformation and a three dimensional. What is the two and three dimension? It's nothing but two means they can say, show the image in a 2D form, that is in a XY direction, and 3D is nothing but you can take a X, Y and Z coordination to show the image or a object on the screen. Okay. So there are main three process of a transformation operations. There are first one is a translation, second is a scaling, and third is a rotation. What is the meaning of translation, scaling, rotation? We can in a translation, using a translation process, we can change the position of a given object. Means simply we can change the given object from one place to another. Okay, here suppose given object is here, we want to change how to display in this. So it traveling from original to what we are mentioning, means we changing the place of a given object, that is a translation. What is the scaling? Means scaling we can increase or decrease the given object size. Okay, here in the translation, it will not affect on the size of a given object, but we are changing the size means we are using the scaling operation. It may be increase the object size or decrease the object size. Okay, so in rotation means it will change the angles. Okay, it may be in a clockwise direction we can change the object or anti-clockwise. Okay, in this video particularly we focus on a translation. Okay, reflection and sharing are the two derived transformation operations are there. Derived in the sense using the basic three methods that are translation, scaling and rotation. Using this we can derive these two operations. One is reflection and second is sharing. Okay, we focusing on a translation. Okay, so in this transformation maps a point xy is considered as the original one and x dash y dash considered as a change of a object. Okay, so we're discussing a translation, right? In this process where the given image or object changes the position. Okay, so the image is transferred or you can say moved to a new position. Then the points is p of xy is for original after the transfers into p dash x dash y dash, where t of x, t of y is a distance of a xy coordinates, means other traveling. Okay, here see the basic first figure is in this coordinate. Okay, so this is indicate with the p of xy. It's a two dimension, that's why we're taking a x and y coordinates value. Okay, so what where it is exactly changing the change of a position, the value of a x and y coordinates represents the t of xy. Okay, so this is gives a distance or you can say a change of position. So p dash x dash y dash is a change object positions. Okay, so with the help of this we can see an example. So we discussed as a original coordinates is a p and the change is a p dash. So how we have to represent the in the matrix. So for translation, we using the matrix as a P equals to T plus P dash, or we can say xy is original equals to T of xy plus of x dash y dash. Here we are not showing the identical matrix. Identity matrix we used to taking for the x y P of x y. You have to multiply with the original xy coordinates plus of your translated matrix. Okay, so this is how we have to represent in the matrix. That is, P dash is x dash y dash equals to T of x T of y plus of x y. You can multiply with the identity matrix. With the help of uh, example we understood. Okay, so here this is an example. Translate a point 2 comma 4 where translate 8 comma 14 and find the p dash. So how we have to go find out this one? Given is p 2 comma 4, that is a x value is 2, y is 4, and translated t of x is 8 and t of y is 14. Then what is the p dash? Here the formula p dash equals to p into of I indicates a identity matrix. That is the identity matrix is represent this. Okay. So how we have to show? First, the given object, according to given you have to put the image. Okay. So now we have to find out the where exactly p dash is occur. So here p is given 2 4, right? You have to multiply with the identity matrix, that is the 1 is to 1, and plus of a translated, that is a 8 comma 4. Okay. So you have to write down all the matrix in a 2 into 2 matrix. Or this is your 2D matrix. So here we get 2 4 plus of, because of a multiply we get a same one, because we have a identity matrix. We are using identity matrix, we get a 2 4 plus of 8 4. What we get? We get a 10 comma 18. Okay, that's a means the where object is displayed now here. So that is a 10 of a x and 18 of a y. So basically originally object is here. After translate it was here. In translation, uh, we have to know this object size will not get affected while changing the position. Okay. I hope this is clear to everyone. Okay. In next video we will cover other topic related topics, that is the scaling and rotation, reflection and sharing. Okay, in upcoming video. Thank you.